Introduction.
One of the long-standing goals of physics has been to understand the nature of atoms. Early in the 20th century, nobody knows how the electrons in an atom are arranged, what their motions are, how atoms emit or absorb light, or even why atoms are stable. Without this knowledge, it was not possible to understand how atoms combine to form molecules or stake up to form solids. In 1803, Dalton set forth his atomic theory according to which the atom was hard, indivisible, neutral particle. The atom underwent significant modifications soon. Two English chemists, William Nicholson and Anthony Carlisle, decomposed water into hydrogen and oxygen using an electric current. Dalton's model of atom could not explain how this could be possible. Michael Faraday could use electricity for electroplating, and he enunciated his famous laws of electrolysis. Each new experiment provided information about the structure of the atoms. In 1875, William Crookes carried out experiments with discharge tubes. He removed air from the tube completely. A beam of current passed from cathode to the anode in a straight line through the vacuum. The beam was called as cathode ray. The name electron was given to the negatively charged particles by Sir J.J. Thomson. Thomson also measured the value of E by m of cathode ray particle. For this work, Thomson won the Nobel Prize in Physics in 1906. From the study of discharge of electricity through gases, it became clear that atom consists of positive and negative charges. J.J. Thomson established that negative charges in the atom are due to presence of electrons. Because the atom is electrically neutral, the number of positive and negative charges, electrons, must be equal. In addition to this, since the mass of electron is too small compared to the mass of the atom, therefore the mass of the atom must be continued in the positive charge present in it. The size of the atom is found to be in the order of 10 power minus 10 meters. According to J.J. Thomson's model for atom, called as Thomson's atom model, an atom is a positively charged sphere of radius 10 power minus 7 meters, in which mass and positive charge are uniformly distributed. The electrons are embedded in the positively charged sphere just like seeds in a watermelon or plums in the pudding. Figure 1. The total positive charge inside the atom is equal to the total negative charge carried by electrons, so that every atom is electrically neutral. The electrons were imagined to be situated in the cloud of positive charge such that the system is stable. Thomson's model and Lennett's model both had certain merits and demerits. It was Ernst Rutherford who solved many problems by doing a series of experiments from 1906 to 1911 on alpha particles scattering. Condensed matter, solids, liquids, gases, at all temperatures emit electromagnetic radiation in which a continuous distribution of several wavelengths is present, though with different intensities. This radiation is considered to be due to oscillations of atoms and molecules. The spectrum appears as a series of bright lines. In such gases, the average spacing between atoms is large. Hence, the radiation emitted can be considered due to individual atoms rather than because of interactions between atoms or molecules. The spectrum of the hydrogen atom was determined first in the late 19th century. At that time, the few lines in the visible region were noted by Balmer, a school teacher in Switzerland. Hydrogen is the simplest of all atoms. Hydrogen always gives a set of lines with fixed relative position between the lines. We will be dealing with hydrogen spectrum in detail in this chapter. Rutherford was the first scientist to give a current description of positive and negative charges within the atom. The basis of this atomic model was alpha particle scattering experiment. This experiment provided very useful information about the structure of atoms. However, he could not explain why atoms emit light of only discrete wavelengths.